Okay, what is in this question? What they're asking? They are saying that two ponds A and B each contain a large number of fish. It is known that 2.4% of the fish in pond A are crab and 1.8% of the fish in pond B are crab. Random sample of 50 fishes from pond A and 60 fishes from pond B are selected. Use a appropriate Poisson approximation to find the probabilities. The two samples contain at least two crabs from pond A and at least two crabs from pond B. So at least two. The case is exactly at least two. Okay. Now first thing is this. Like this is 2.4% when I'm talking about 2.4%. So what I can say, if I'm dealing with pond A and then pond B. So the probability for that one for pond A is 0.024 and for pond B is 0.018. Is that clear? And for this one, we have 50 fishes, like n is exactly 50 for pond A and n is exactly 60 for pond B. Okay. Then furthermore, when I proceed further, so what we have to do, like we have to use the Poisson approximation to find the following probabilities. So we have to deal with both of them. But the thing is that both the probabilities will be multiplying together. And because and is exactly the condition in the probability we have studied in AS level, that when we are having this kind of cases with the latter connection of and, so it means we are going to multiply. These are the branch probabilities that we are going to multiply together. Okay. So now what I will do for pond A, first I will calculate they were talking about at least two. So it means they are exactly dealing with x is probability x is greater than equal to 2. Okay, at least 2 is this one. So how can we calculate that one? 1 minus probability of x less than equal to 1. Is that clear? And this one is also probability of x is greater than equal to 2, which is also dealing with this one. 1 minus probability of x less than equal to 1. But there is a problem, like we do not have lambda right over here. So lambda will be n into p in that case, and n is 50 and p is 0.024. What is the lambda for pond A? 1.2 I'm getting, and for this one is 60 into 0.018, 1.08. Okay, so now when we are calculating for pond A now, when we are dealing with pond A, exponential to the power of negative 1.2. Now I'm going directly that way, na? Like 0 factorial upon 0, sorry, 1.2 to the power 0 and upon 0 factorial plus 1.2 to the power 1 divided by 1 factorial. Okay. It is going to tell me that the final answer for this one is 0.3373. Okay. And for the next one, pond B. 1 minus exponential to the power minus 1.08, and it is exactly 1.08 to the power 0 divided by 0 factorial plus 1.08 to the power 1 divided by 1. So 0.3373 multiplied by 0.894. It is exactly 0.3015. 462 is the complete answer, and I can just round it to 302. Okay. And verify yeah, the explanation is most important. That starting explanation is most important. Like if you just make all the notes rightly, because when I was a student I studied that one, there was too much complicated for me because my that was my teacher, na, he couldn't explain me well. So at that time I was, yeah, S2 is exactly easier than S1 because of that. There is no permutation combination, and there is only that, and there is no tricky questions. Exactly, the follow the rule, and you have to just follow that assumptions, na. That's the main important thing. And verify my answers as well, na. No, I'm not checking. That's why I'm asking you that if you are calculating that thing, na, to verify my answers as well. We're just copying that one. I thought that you were solving. That was 16 to 0.18 is 1.08. Okay. Okay. Yeah, this was around 0.7064. Now I'm getting to the point. Hmm. My calculator is too much irritated. Hmm. Oh, that's perfect. Okay. Should we proceed with part two? Y- Yeah, we just did. I. Not the probabilities. It will be just combining the distribution. So it is going to be the lambda 1 and lambda 2 will be together now this time. So we can say that for part 2, lambda will be equal to 1.2 plus 1.08. So it is going to be 2.28. 2.28, that one, and at least 4 they are asking about. The probability should be x greater than equal to 4, and the probability of x greater than equal to 4 is equal to 1 minus probability of x less than equal to 3. So we can do 1 minus exponential to the power minus 2.28, and it will be 2.280 upon 0 factorial plus 2.28 1 upon 1 factorial plus 2.28 square upon 2 factorial and plus 2.28 cube upon 3 factorial. So it is going to be yeah, it doesn't matter, you can directly get one. Yeah, it is 0.4910 and 1 minus 0.4910 is exactly 0.509. So I forgot to put the square and the cube as well. If I go for 4 na, so it will be keep going till infinity. How can I go for that one? Have you forgot? Yesterday, yeah, yesterday we discussed that issue, no? 0.197. Should I proceed with the next part? The random variable x and y have the distribution of Poisson of lambda and Poisson of mu respectively. It is given that Poisson of x, oh sorry, p of x equal to 0 and p of y equal to 0 square, and p of x equal to 2 k times p of y equal to 1. So where k is a non-zero constant, find the value of k. It's an easy question, that we have two different assumptions. Now we have to just simplify and figure out the value of k for that thing. So the random variable x, first random variable x is exactly having that the parameters for that one is lambda, and second distribution of y is having the parameters that is mu. Okay, so we have to just follow the steps. Sorry, no, this is not the same. Yeah, it looks similar because that you are having the right conditions, that you have learned the exactly you have learned the conditions. Maybe the conditions will be in your mind. Definitely you are thinking that is the same question, but when the student do not study according to the concept, na, so it will be very complicated to understand the question what to do and what not to do. Exponential minus lambda to the power 0 divided by 0 factorial is equal to, and exponential to the power minus mu into mu to the power 0 divided by 0 factorial to the power of 2. So exponential minus lambda will be equal to exponential minus 2 mu, because nothing will be remaining. And I can say that I do not need right now. I am living like this. And the second condition that they have provided me, that was P of probability of x equal to 2, the probability of k times probability of y. So exponential minus lambda and lambda to the power 2 divided by 2 factorial will be equal to k times minus mu to the power 1 divided by 1 factorial and 2. Okay, so we have to figure out the value of k. If I simplify that side, minus lambda to the power 2 divided by 2 factorial is 2, and k times it can be mu to the power 1 now, exponential minus 2 mu, and by this equation we can take out some values like both bases are equal, so minus lambda will be equal to minus 2 mu and lambda will be equal to 2 mu. I can say that, and I can also say that uh, okay, we will cancel that one. I am just going to put that value inside this one. Mu can be equal to lambda by 2. Okay, so exponential minus lambda square divided by 2 is equals to k. Lambda can be equal to lambda by 2 and exponential to the power minus, that was 2 mu, no? So it will be minus lambda. So these two terms can be cancelled together, hmm, and there will be lambda square upon 2, and I can send that one on this side. 2 upon lambda will be equal to k. 2 and 2 will become lambda. So it means according to that stuff that k should be equal to lambda. That's what I'm thinking. Hmm? You were asking. No, it's not a show that type of question. They were saying something over here. Find the value of k. They were exactly asking about the value of k. Oh, when I applied the square on this one, the square will be applying on this one as well. It's 2 also. So it means it is square over here. So if it is a square, so it is going to be 4 over lambda square. So lambda square and lambda square will be cancelled. So 2 into 2. Yeah, k will be equal to 2 in that case. Is that clear? You there? Uh, Okay, so we have the another question right over here that is exactly asking about the number of orders arriving at the shop during an 8 hours working day is modeled by the random variable x with a distribution Poisson 25.2. It means the lambda means the parameter is exactly 25.2 for that thing. State the two assumptions that are required for the Poisson model to be valid in this context. Uh, Orders arrive should be at a constant rate. Orders arrived should be at a constant rate because the fourth assumption of the Poisson is exactly the rate should be same for every particular unit. And the second assumption should be orders arriving are random, and orders arrive independently for all the four assumptions. No? And the fourth assumption was singular events. Order arrive single. So these are the four assumptions that, and you can write any two of them. Are you there? You can write any two of them. When I go for B part 1, find the probability that the number of orders that arrive in a randomly chosen 3 hours period in between 3 and 5 inclusive. So that was a 8 hours period and that was a 3 hours period. So in that case we have to change our lambda for first thing. Na? And in between 3 and 5 inclusive. So from 3 to 5 we can just proceed with this. So in that case if we are dealing with this one, so 8 hours period was having 25.2. Now we are having 3 hour period. So what should be our lambda for this way? 8 lambda equal to 3 multiplied by 25.2 and lambda will be 3 over 8 multiplied by 25.2. So my new lambda is exactly where were you? No. I was just asking where were you? I was just asking you again and again. Really? I was saying that are you there? Are you there? Are you there? And you were not answering. Oh. So lambda will be equal to 9.45 for that one. And now they are asking find the probability that the number of orders that arrived in a randomly chosen 3 hours period between 3 and 5 inclusively. So 3 and 5 it means both are included. So we need to figure out the probability for 3 less than equal to x less than equal to 5. So 3 and 5 is included, so it's quite easy that 3, 4 and 5 should. So it means it should be x equal to 3, x equal to 4 and x equal to 5 for this one. I can do that. Exponential minus 9.45 and we will starting from 3. So 9.45 to the power of 3 divided by 3 factorial plus 9.45 to the power of 4 divided by 4 factorial plus 9.45 to the power of 5 divided by 5 factorial. So here we can say that it will be completed, and yeah, the next class we will proceed with the new topic. Okay, yeah, exactly, this is the same thing. 8, 6 and 6, so I am getting 0.866 for this one. Yeah, it's a short syllabus, not a long one. But you will be having a problem in hypothesis testing, but I do not think you can do that. Yeah, I will explain you. It's easy also. Okay, this is done. Now, what is the next part? Find the probability that in two randomly chosen 1 hour period, exactly one order will arrive in 1 hour period, and at least two order will arrive in the other 1 hour period. Okay, so we have to just change the lambda for this one because the lambda is not correct for this condition. No? We were dealing with 8 hours for 25.2, and they are now dealing with 1 hour. So it's B part 1, that the B part 1 we have done. Now I am going for part 2 over here, and first I will calculate my lambda, that was 8 to 25.2. Now lambda will be what when we are dealing with 1 hour period. So lambda will be 25.2 divided by 8 is exactly 3.15. This is my new lambda for this one. Now what we have to do, exactly one order will arrive in 1 hour period, and at least two order will arrive in 1 hour period, in another 1 hour period. So we will take out the probability for 1 hour period exactly, and that was at least. Okay, so 1 hour period, it means it should be equal to 1. Okay, is that clear? For this one I can say exactly minus 3.15 to the power of 1 divided by 1. Okay, and another case was x is at least 2, so greater than equal to 2. It must be 1 minus probability of x less than 1, less than equal to 1. Less than 2. So in this case we need the probability for this one. What we are getting, exponential to the power minus 3.15 into 3.15, that is exactly equal to 0.135. For this one, and for this one I must be having this condition minus 3.15. It will be 3.15 to the power 0 divided by 0 factorial plus 3.15 divided by 1 as well, means 1 factorial. So I will directly get that answer. I'm getting 0.8222. Yeah, it is easy, na? Like if you take something common, so it will be fine. Now what we have to do? We have to multiply both of them because there was a case of and. 0.135 multiplied by 0.8222. 0.135 into 0.222. That is exactly equal to 0.110997. This is the complete answer that we are having. And it can be 0.111. But the problem is this, like it can be in two different manners. No? Like there can be a repetition of this probability. So we can add them twice or we can just multiply it by 2. And for part C, the shop can only deal with a maximum of 120 orders during any 36 hours period. Okay, use a suitable approximation to find the probability that a randomly chosen 36-hour period there will be too many orders for the shop to deal. 36-hour period. This is the same thing for orders. Same thing. Like the shop can only deal with a maximum of 120 orders. That will be the n during any 36-hour period. So for this one, you have to calculate your lambda for that one and use a suitable approximation distribution to find the probability that in a randomly chosen 36-hour period, there will be too many orders for the shop. What should be the lambda for this one? No? Like we will go for the normal distribution, it's understood. Just a second. That was for 8 hours. The start of the question you are talking about. 8 hours for 25.2 and that is 36 hours. Yeah, but yeah. This part you're talking about. No? This is not connected. Actually, C is connected with this one. Lambda is exactly 113.4 for this one. And for checking the mean, there will be mean is gonna be NP for that thing. No? The probability of success is not this one. Okay. So this is going to be my mean as well. Mean is exactly 113.4. And this is going to be the variance as well. That will be 113.4. So we are proceeding with the normal distribution right over here because n is exactly greater than 30. So we can say that. Okay. So if I'm dealing with that one, yeah, sorry. What was the other one? Other one mean, your mean should be greater than the given, I guess, the given mean. Oh, sorry, your mean should be greater than 10. Sorry, what is in the mark? Greater than 10. It must be greater than because I've seen that in the syllabus now. So if you are using that one, it means your mean, this is the mean, it is greater than 10, so you can use the normal distribution. So and 113.4 and 113.4 mean and variance. And what was that thing? By how we are going to calculate the probability? Maximum 120. There are too many orders for the shop to deal. So it is going to be 120 orders maximum. So if I am interested to know about the probability of 120, too many, so greater than that, 120. So 120.5 must be subtracting by 113.4. divided by under root of 113.4. Actually, the thing is what they are exactly asking about. No? They are asking about x is greater than 120. And when we are just converting the normal distribution and something like that from any another distribution, so there are some particular rules. So what I will do, I will just exactly add 0.5 in that case, na? For converting for going for the approximation right over here. Okay, and this is also cannot be calculated, so I can do x is less than 120.5. Is that clear? So first I will calculate the probability for this thing, and then I will just subtract it from 1. Okay. Yeah, exactly. Continuity correction. I was not getting the name of that particular thing in my mind. That's why I told you. Sometimes it happened that I forgot all things, a lot of things. That is exactly 0.6667. So 1 minus. Oh, we have to check that one. 0.66667. So I think I should make it round off. Can you figure out the probability from by checking the table? 0.667. This one. 0.626. 0.7454. Okay. 23. Check the probability in normal. Thank you. Normal distribution table. So 0.667, if I go with it, sorry, 0.7477, it must be 0.2523. That will be the final part that we were solving. Yeah, now we can proceed till here. And now we will proceed with a new topic in the next class. Okay? And see you, take care. Allah Hafiz.